Good morning, everyone. Today's session is on managing Hadoop file automation. So, I'm Karthiyan, working as an assistant professor in the Department of Mechatronics Engineering at SNS College of Technology. So, let's dive into the topic. So, by the end of the lecture, you will understand how Hadoop stores, manages, and automates large-scale data and the tools that make it all work together. So, coming to the introduction to Hadoop, let's start with the basic. What is Hadoop? Simply put, it is an open source distributed framework designed to store and process massive amounts of data across clusters of computers. It has three core components like HDFS, which handles the storage, MapReduce, which handles processing, and the YARN, which manages resources across the cluster. What makes Hadoop stand out is that it's scalable. You can keep adding machines as your data grows. And fault tolerant, meaning if one node fails, your data is safe. And because it runs on commodity hardware, it also cost effective compared to the traditional system. Followed by the HDFS overview. Now let's zoom into HDFS, the Hadoop distributed file system. Think of it as the backbone of the Hadoop. It follows a master slave architecture. The name node is the master. It doesn't store data itself, but it maintains all the metadata, the file names, directory structures, and where each piece of data lives. And the data nodes are the slaves. They physically store the data blocks on their local disk. An important concept here is the block size. By default, HDFS breaks files into blocks of 128 MB each and distributes them across data nodes. This design allows parallel processing and efficient data retrieval. And how we can storage the data in the Hadoop is that we know about HDFS. So let's understand how data is actually stored. When you upload a file, it's split across multiple nodes. This is distributed storage. To ensure the reliability, Hadoop creates 3 copies of each data block by default. This is called replication. So even if two nodes crash simultaneously, your data is still intact. This is what gives Hadoop its fault tolerance. And when your data volume grows, you simply add more nodes horizontally. No need to upgrade expensive hardware. This is horizontal scalability in action. And automation in Hadoop data management. This is where it gets interesting. Managing big data manually is not feasible. So Hadoop relies on automated workflows at every stage. First stage is data ingestion. Tools automatically collect data from the IoT sensors, database, logs, or APIs without manual intervention. Then comes automated processing using MapReduce or YARN managed jobs. After processing, data transformation is handled through ETL or ELT pipelines that clean and restructure the data. Finally, workflow orchestration. Tools like Uzi and Apache Airflow acts as schedulers, triggering jobs at the right time in the right order. And the mind map of the today's concept, a mind map connecting all key concepts we are covering today. So you have HDFS architecture at the core, connecting to data storage and replication, automation and workflows. So Hadoop ecosystem tools like Hive, Pig, and Scoop, best practices and challenges. So think of this as your conceptual map. Every topic we discuss connects back to the central theme of managing Hadoop data effectively. And the best practices of managing the Hadoop data security is critical. So you must implement authentication with Kerberos and authorization using Apache Ranger to control who accesses what. Performance optimization involves monitoring cluster health using tools like Ambari and tuning configuration like block size and replication factor. So scalability planning means designing your cluster with future data growth in mind. Don't just solve today's problem. Regular monitoring ensures you are tracking key metrics and setting up alerts before issues escalate. And finally, backup strategies. Snapshot and disaster recovery planning are non-negotiable in any production setup. And the tools for Hadoop data management, then that is Hadoop does not work alone. So it has a rich ecosystem of tools. So Hive lets you write SQL like queries on HDFS data. Great for analysts who know SQL. Pig is a scripting language used for data transformation tasks, especially in ETL pipelines. Scoop is your bridge between Hadoop and relational database. It imports and exports data between HDFS and a system like MySQL or Oracle. Then Hadoop base is a NoSQL database built on HDFS for real-time random read or write access. Think of it like a database within Hadoop. And OZ is the workflow scheduler that coordinates the jobs in the right sequence at the right time. And what are the challenges and solutions? No technology is without challenges. So data consistency is a major concern in distributed system. Apache Zookeeper coordinates processes across nodes to ensure consistency. Node failures are inevitable in large clusters. Hadoop handles this automatically through its replication mechanism. Network latency can slow things down. The solution is data locality, which means moving computation to where the data sits rather than moving data across the network. And resource management, where multiple jobs compete for resources. Yarn scheduler ensures fair and efficient allocation. And to wrap up, Hadoop is a powerful framework for managing big data at scale. We saw how HDFS provides distributed fault-tolerant storage. We understood why automation is essential from ingestion to orchestration. We explored the key tools like Hive, Pig, Scoop, and HBase that powers this ecosystem. The key takeaway for your exams and projects is the Hadoop strength lies in combining distributed storage, automated workflows, and a rich tool ecosystem to handle data at scale. Thank you.